In this video, we're going to explore slope-intercept form. And we'll start out on desmos.com doing some graphing. So here we have a coordinate plane, which is a way to plot xy coordinates, right? Plot in 2 dimensions. And over here we can graph some lines. So let's start with equations with just one variable, like y equals 4. Well, you can see that produced a horizontal line that goes through this point 0, 4, and every point on this line has a y coordinate of 4. X could be anything, but y is always 4, which matches the equation of the line. The same thing will happen if we make a line like y equals negative 2.5. You see this blue line down here. Every y coordinate on this line is negative 2.5. And if we make a line y equals 0, that actually graphs the x-axis, which is kind of strange, right? That the line y equals 0 ends up graphing the x-axis, but it also makes perfect sense if you think about it, because along this x-axis, every point has a y coordinate of 0 because every point has really no height, right? It's lying flat right on the x-axis. So x lines with an equation of x equals are going to be similar, but they'll be vertical lines. So if x equals 4, it's going to be a line that contains all the points in the universe that have an x-coordinate of 4, meaning that are 4 to the right of the origin. So here the y-coordinate will shift, but the x-coordinate will always be 4. So I'm going to regraph y equals 4 so you can just compare those two. Then let's graph some more x equals lines. Let's say x equals negative 3.0125, right? Here, I'll change that since it rounded. X equals negative 3.013. Every point on this vertical line is 3.013 to the left of the origin. And if we graph the line x equals 0, it's going to actually graph the y-axis, because when x is 0, we're not moving to the left or right at all, we're just going straight up and down, and that graphs the y-axis. So that's what happens if you have equations that are y equals or x equals. But what if we have an equation with y and x in the equation? So that's going to produce a slanted line. And this line y equals x is going to contain all the pairs of values in the universe where y equals x. So 2, 2. If y is 2, x is 2. 4.05, 4.05. Negative 3.9, negative 3.9, right? Along this line, on every single point on this line, y equals x. Well, let's play around with this a little bit. Let's put a coefficient in front of x. Y equals 2x. So now you can see this blue line is steeper than the red line, because when x equals 1 here, y equals 2. Y equals 2 times the x value. So every point on this line, like 2.01, 4.02, for every point in this line, the y-coordinate is double the x-coordinate. And if we increase the coefficient, we'll continue to produce steeper and steeper lines. Right? This green line, every y-coordinate would be 3 times the x-coordinate. So when x is 2, y would be 3 times 2, which is 6. So as you can see, the lines keep getting steeper. Do one more. All right. Well, what if the coordinate in front of x is a negative number? So instead of 2x, it's negative 2x. And I'm going to fix this red line to be negative x or negative 1x. Those are synonymous. Those are equal. Well, this blue line, y equals negative 2x, is sloping in a different direction. It's going down from left to right, but it's still steeper than the red line, and the same thing will happen as we get more negative. It'll produce steeper and steeper lines. So if I look at this green line, y equals negative 3x, let's say x equals negative 2. Negative 3 times negative 2 is positive 6, so y would be positive 6 when x is negative 2. Let's see if I can produce that point like this. There we go. Let's go back to positive slopes for a second. What happens if the coefficient of x is less than 1, is a fraction? Well, as you might guess, that's going to produce lines that are less steep. So if y equals 1/2 x, when x equals 4, y equals 2, because 1/2 of 4 is 2. When x equals 6, y would be 3, because 1/2 of 6 is 3. And if we get, as we get closer to 0, ooh, interesting, we're going to get flatter and flatter lines until we hit 0, and when y equals 0x, well, 0x is just 0, that's the same as y equals 0, and that's the x-axis. Alright, one more thing to explore. What happens if we add or subtract something after x? So instead of y equals x, what about y equals x plus 3? Well, since we haven't changed the coefficient in front of x, we haven't changed the slope, but we've shifted the line up 3 units. So now when x equals 0, y equals 3, because 0 plus 3 is 3. When x equals 2, y equals 5, because 2 plus 3 equals 5. And if we increase this, we're going to just shift it up more and more. And if we subtract, we'll be shifting it down. So let's take a look at an equation like y equals negative 2/3, so a negative slope, flatter than 1. If I do the same equation, but I subtract 5, it'll be that same slope, but shifted 5 units down. So this type of equation, y equals something x plus or minus something, has a special name in math. It's called slope-intercept form, where the coefficient of x, the number in front of x, is the slope of the line, the steepness of the line, and the number after x is the y-intercept. So here, when it's negative 2/3 x minus 5, the y-intercept is 0, negative 5. That's where the line crosses the y-axis. And if we have this same slope, but plus 3.5, the y-intercept of that line where it crosses the y-axis is going to be 0, 3.5. When x is 0, this term cancels out, and y just equals 3.5. So now we're going to take a look at a Khan Academy assignment called Slope-Intercept Intro, and we're going to use what we just learned to answer these 4 problems. Alright, the first one, what is the slope of y equals 4 minus 2x? So for slope-intercept form, we want it to look like this. Y equals something x, and in algebra we call that something m. So m is going to be the slope. Y equals something x plus or minus b, where b is the y-intercept. So the equation they gave us here kind of tried to trick us because they flipped it around a little bit. So we just need to rewrite it. Y equals negative 2x plus 4. And now we can see that the slope is negative 2 because that is the coefficient of x, the number that's in front of x. So really, slope-intercept intro is just about understanding the template and reading the template. You're not solving anything. You're not doing any calculations or operations. You're just showing that you understand this equation template called slope-intercept form. Number 2. Complete the equation of a line whose slope is -2 and y-intercept is 0, 3. Well, the slope is the number in front of x, so y equals -2x, and then the y-intercept is +3, so +3. That's the equation of this line. What is the y-intercept of y equals 5x minus 1? Well, the y-intercept is in this slot, and it's -1. So the y-intercept is going to be 0, -1. Right? The y-coordinate is -1. And if I look and graph this 0, -1, it's going to be right there on the y-axis. Final one, what is the slope of y equals -4? So at the beginning of the video, we looked at equations like this. When y equals -4, that's going to be a vertical line, sorry, a horizontal line down here at -4. And when a line is perfectly flat, the slope is 0. Another way we could think about that is we could rewrite this equation as y equals 0x minus 4. Since there's no x, and if we had to put a coefficient in front of x, right, we could put 0 to cancel out and make it disappear. So that would be the slope, 0. So again, for slope-intercept intro, you want to remember that when you have a line in slope-intercept form, the coefficient of x is the slope, and what comes after is the y-intercept.